Okay, hopefully you can see this okay, Eddie. So what I'm going to do first is just create a basic alignment here on the block. And there's a macro for that here, so I'm just going to hit 321, which is a 3-point plane, 2-point line, and then a single point. The digital readout here shows the coordinates, and then this little status window shows that we're waiting for 3 points. So what I'm going to do is take 3 points on top of this block to establish a plane, and that'll be our reference 0 plane. Hopefully you can see this okay. Hopefully you can see this okay. And then, shoot, choke this down a little bit. And then I'll do a 2-point line in the front of the block, and then just one on another side. Okay. And so you can see in this little window here, it's just asking if the points that I've assigned are a 3-point plane for Z, 2 points for a line in the x-axis, and then 1 point for the y-axis. Sorry about moving the camera, I'm just trying to make sure you can see it. So I'm just going to hit OK. You can see there is a graphical representation of the surface plate of our machine. Yours would be smaller because this is quite a large machine. And then I have right here a trihedron in the software showing the 0 for X, Y, and Z on the part coordinate system. Now I'm going to just come up here to the main menu on the software, and I'm going to go over to scan. I'm going to hit scan cloud and then 2D. You can see a little window pop up here. I'm going to put probe compensation on. I'm going to define the plane as I want to scan in the XY plane, and I'm going to go about 5 millimeters down from the top surface of the block. So you can see I typed in -5 there. And then in the scanning flow, it allows you to do 2 different types of scans. You can do a closed scan, so it'll basically have a start point, a direction, which is what is shown here. S is for start, D is for direction, and then E is for end. Since we're going to scan around the perimeter of the block, we're going to call it a closed scan, so it basically will start where it ends. So we just have to define 2 points, which is the start and the direction. So I'm going to click define all points, and then it basically is just waiting for me to take the 2 points. And so I'll use the joystick here to just drive the machine, and I'm just going to simply come to the front of this little pocket, and I'm going to give it a start point, and you can see the digital readout, or the status window is saying there's 1 point taken, 1 point left. Then I'll just move over and take another point, and that just tells it which direction I want it to scan in. So you can see it assigned those coordinates inside the window here. And if I move the window, you can see in this graphical representation in the CAD viewer here, you can see it took 2 points. And this is just a little representation of the stylus. And we can turn that off or turn the probe back on and show the entire probe, but it kind of gets in the way. So I usually just turn that off and then just tell it to show the ruby ball only so it's not in my way. Okay, so now we have our scanning flow assigned, and I'm just going to hit create path, and you can see here it has basically the start and end is basically in the same point, and there's a little green arrow showing the direction that it's going to go in. And once I hit this OK, it's going to come back out to a window here, and you can see that it says just measure or back. I'm trying to get the camera set up here so you can see the scanning and the CAD viewer. And now once I hit measure, you'll see the probe come into the part and then start scanning around a feature. Every 200 points or so, it's going to update the CAD viewer with all of the points for the point cloud, and you can see the probe scanning around the part here, and you'll see it's taken 1,000 points, 1,200, each 200 it'll update. And you can see this this model showing up here, and this is just the point cloud. Okay, now the scan's completed, and it took a total of 2,130 points, and now we're good. It's actually processing this data right now. My computer's not the fastest thing in the world here, so it takes a few seconds for it to process the couple thousand points of data. Once it's completed, there it shows now that we have our point cloud, which is now orange. It looks like a curve, but it's not really a curve yet. That's basically just the points that we see, and then we can see over here in the feature database we have a point cloud. Now to turn that into the DXF file, we come up here to the CAD editor, and if I click on that, it opens up a CAD editor. Now we just go to, where's my mouse? We go up here to curves, and then I say create curve, and basically either I can drag this point cloud into that cloud name, or I could right click in here and just select off a menu cloud. I'm going to say I want this to be a closed curve, so it'll be just one complete curve, and then hit OK, and it'll process it. Again, my PC is not super fast here, but it'll just take a few seconds here. And then it pops back out to this CAD editor menu, and we can see now that we have curve 1. Now if I just highlight that and select export DXF, and then basically just give it a name here, and we'll leave it as default, and that's pretty much it. And then you just navigate to wherever you had that saved out as, and I can save this project here, and you just navigate to wherever you have that saved, which I have a folder for you called WireTech, and you have the curve in there. So that's kind of an overview of the process. It's pretty fast. I'm going to end the video here because it's getting pretty long. It's probably going to be a huge video. So I will talk to you after you get this.